Hi everyone, we are team number 10, and my name is Shin Sun-ung, the narrator of this team. We selected London Aquatic Center in this semester, so we're gonna explain about the London Aquatic Center at this presentation as well. This building is designed by famous architect Zaha Hadid. Her full name is Zaha Muhammad Hadid, also known as Queen of Curve. She was born on October 31, 1950 in Baghdad, Iraq. She is specifically famous for her radical deconstructivity designs and her groundbreaking achievements as a woman in the field of architecture. She is the first woman to receive the Pritzker Architecture Prize in 2004. She has designed many buildings such as Maxi, Bridge Pavilion, Magis Central Contemporary Art Center. Anyhow, let's focus on our building. Our building is built for London Olympics. Its type is swimming pool, which is used by athletes on the Olympics. Client is Olympic Delivery Authority. Its capacity is 17,500, built from 2008 to 2011, and construction cost is £269 million, and net floor area is 42,866 square meters. Next, let's talk about inspiration. The architecture concept of this London Aquatic Center is inspired by the fluid geometries of water in motion, creating spaces and a surrounding environment that reflect the riverside landscape of the Olympic Park. This building is designed to reduce the record of athletes as much as they can by allowing the water circulation to stop immediately during the game and flattening the pool walls and the water levels, allowing overflowing water to fall directly into the drainage groove next to the pool. This can effectively reduce the water resistance and hence reduce the record. These are the very first ideas produced by Zaha Hadid. Even for the very first drawings, the design style of the practice can be seen. A key principle that was followed throughout the design and the development of Aquatic Center was that the building should convey the idea of liquid and fluidity in its form, and the repeated similar designs showed this in the form of flowing roofs. Originally, the design for the Aquatic Center covered many larger areas, and the first few models made show an attempt to draw the desired fluid shape from the topography of the site. Although those first designs were not chosen, still the Aquatic Center remains its fluid shape, along with the surroundings. One of the key reasons that London won the bid for the Olympics was that there was a long-term plan after the Olympic Games were finished. Accordingly, there were also after plan of the Aquatic Center. The notable element of the design is the temporary seating stand, the wing projecting from either side of the building. These wings allowed to make the building capacity to 17,500. This wing design makes the building serve both long and short-term goals. Perhaps the most notable part of Aquatic Center is its roof, designed in wave-like shape to represent the fluidity of water. The roof is primarily made of two materials. The underbelly and facade are made of red laurel. The roof, which cannot be seen from ground level, is made from highly flexible aluminum. The upper facing side of the roof is a complex 3D double curved shape. You can simply picture its design by thinking of Pringles chip. The facade of the roof was carefully chosen to complement the curvature of its geometry. The final choice of red laurel was chosen for two key reasons. In terms of durability, the wood is highly moisture resistant and has naturally occurring oils that deter insects and fungi. The second reason is that when weathered, the wood takes on reddish gray color that was desirable to give continuity from the metal gray sheets of aluminum that made the top of the roof. The roof is referred to as floating because of the way it meets the ground. The red laurel becomes lead resistant if it remains in contact with ground for a long time. To overcome this, a podium separates the roof from the ground. A timber cladding stops 200 mm above the ground, and under it there is a sloped drainage. Textured asphalt rises towards the roof and gives the impression that it floats. Inside the building, many elements that are made of concrete in beautiful shapes. The roof of the training pool is cast concrete rebar of large geometric ceiling coffers. A layer of light diffusing fabric that doubles as an acoustic buffer sits above the coffers. This lighting gives a skylit ambience to the pool. The design of ventilation system is also amazing. It has been cleverly integrated into the design of this building. The grass hill at the southern end of the building conceals vents that draw air into the building. The flute-shaped design roof requires detailed design plan to engineers for fabrication and erection. There were several problems for flute design. First is long span design, and the second is the wind load being broad area. Third is the shape becomes thinner go to wings. These were main challenges for engineers to make the flowing geometry that Zaha Hadid defined. Let's see how they resolved the problems. For long span design, normally engineers use the arches, but at the London Aquatic Centre, the other solution is needed to minimize the interdependence of the roof and substructures and make easier. So, instead of arches, the engineers used a series of trusses and spanning in the long direction. The trusses were supported at just 3 points. It makes an effective structure with limited supports. Wind load was also a key design problem. The roof needed to resist the wind loads in broad side area. To analyze the wind loads, they used the wind tunnel testing that is commonly used to skyscrapers or automobile and aircraft design and so on. Through extensive use of wind tunnel testing to gather simultaneous measurements, the refined wind loads were determined. Last design issue was that the roof becomes thinner and thus go to wings. In the center, the depth was used to span the truss distance, but at wings, there's no depth, so it cannot support itself. To support the wings itself, the engineers used the cantilever wings, meaning that the wings could support itself. The result is an efficient and buildable structure. It is our team's plan. In the first and second weeks, we looked at the overall information of the building. In the third week, we focused on the design characteristics of the building. In the next 4 weeks, we will look at the site and the problems that exist in our building. This slide consists our role of this week. Lee Junsu, team leader, researched the design issues about this building. Ko Jae-sung made a PPT design. Lim Hyung-gyu and Yang Jae-young researched brief information and design issues. And I, Shin Sun-woong, recorded, screen and took narration of this video. Thank you for listening our presentation.